Hey everybody. Just so you're aware, the examples that we're going to be doing with serial communication between p5.js and your microcontroller will only work if you're using Google Chrome. Firefox, Microsoft browser, I think it's called Edge, Safari, these will not work. The only browser that these work with at the current time is Google Chrome. So if you aren't using Chrome, please download it. You can see the URL up here. It's google.com/Chrome. Um, and if you're having difficulty, just make sure that you're actually using Chrome. I foolishly spent half an hour this morning hitting my head against my desk because I was using Safari by accident. So, just keep that in mind as we move forward. Um, it's a stupid problem, but it's a problem that we have to deal with. Now that you've got your system set up, what we're going to do is send data from a microcontroller to a p5.js sketch. In this example is going to be really straightforward. We're going to send a value of 1 or 0 from our Arduino to p5.js. When we press the button, we'll see the value in our sketch, and we'll also change a shape that's being drawn on screen from a circle to a square. So it's a introductory way to start to think about this. After this, we'll start to talk about variable resistors, so having you send a range of data, and we'll also talk about sending data back and forth between P5 and the microcontroller. But we're going to start out with this simple example. You can see here, this is the circuit that I've built. I've got a push button right here that's connected to power on one side. And then the other side I've got connected to digital input 2, pin 2. And that same pin, we've got our pull down resistor right here. This is a 10 kilo ohm resistor that I've connected to ground. So remember, the purpose of this pull down resistor is so that your microcontroller has a reference to ground, so you get accurate readings when you're interacting with your circuit. So this is the circuit right here, and the Arduino code looks like this. It's fairly straightforward. We've got a constant named switch pin, and that is identifying what pin the button is connected to. We've got a variable right here that's going to hold the value that the microcontroller is reading. So it's called switch val. It's either going to have a 0 or a 1. In the setup, we've got two things. The first one is we're setting the pin mode of that switch pin to an input right here. And then after that, we start serial communication. Remember, we say serial.begin 9600, where 9600 is the speed at which the microcontroller and the computer are going to be communicating with one another. By default, the P5 serial server library expects things to be communicating at 9600 baud, and that's a totally fine number to use. And so that's what we've got in right here as our argument. In the loop, we're reading the value from the switch pin and we're storing it inside of a variable, switch val. So when the button is pressed, we've got a value of 1. When the button is not pressed, we've got a value of 0. Here we're sending the value out to the serial port. We are not sending it out as a byte. So I'm just going to fix that. So when we're saying serial.println switch val, what's happening is we're sending that 0 or 1 with essentially the equivalent of the enter button on your keyboard following it. So after that, we've just got a short delay of 10 milliseconds. That's just so we don't overload the serial buffer on our computer. But this is the sketch. It's fairly straightforward. So I'm going to go ahead and upload this. You can see right here, I've got my circuit that I've got connected right here. Um, this is the pull down resistor. Here's the switch, power, input, and ground, right? So I'm going to upload this to the microcontroller. There we go. We've uploaded our sketch. So if you want to, you can check in the serial monitor to see what is going on with the microcontroller. So I'm going to, under my tools menu, open up the serial monitor, and I need to bring this over from the other screen. And so here we've got the values coming in from the switch. You can see it's just a string of zeros. And then when I press the button, it changes to 1. Right? So we know this works. Now I'm going to close the serial monitor, and I'm going to just minimize the Arduino software. Only one thing can be talking to a serial port at any given point in time. So if you have the Arduino serial monitor open, you won't be able to communicate with your processing sketch in the background. So it's really important to make sure that you know what is and what is not working at any given point in time. So from here, what I'm going to do is I'm going to open up that P5 serial control application that you downloaded previously. Let me just move that out of the way. And so I'm going to open this up. And when I do, I get a window that looks like this. So you'll see on here, there's a list of the available ports. So these are the serial ports that your computer is currently connected to. This on my computer and on Linux machines, you'll see something that says dev/tty dot, and then a string following it. You'll see that on both Mac and Linux. On Windows, what'll show up are things called COM ports. So it'll say COM, and then it'll have a number after it. So COM7, COM8, COM2. Um, and so this string right here, this dev/tty.usb modem 143201, this is my microcontroller. If I were to go back and look inside of the serial list in the Arduino software, we would see that my Arduino Nano is connected to this port right here. So this is the port that my microcontroller is on, and this is something that we need to know in our sketch. We'll talk about that in just a moment. So the P5 serial control application makes a bridge between the serial port in your computer that the microcontroller is connected to and the sketch that's running inside of a browser. Browsers don't have native serial functionality, and so this application serves as that bridge. It starts a local web server on your computer to communicate with your sketches. So um, this is really all you need to do in order to, with this application, you just need to open it up, right? And this, all the handling of sending and receiving information actually happens inside of your P5 sketch. And none of it happens here. This is just an application that you need to have open in the background in order to make that connection valid. So I'm just gonna, now that I've opened this, I'm gonna minimize it. And we're gonna take a look at my P5 sketch here. So before we get into the sketch, I wanna point out the index.html file. So typically when you're writing a p5.js sketch. Inside of your index, you've got, inside of the head tag, you've got something that's pointing to the p5.js script, right, the library itself. And then you'd have another sort of link to any other libraries that you're looking to include, and then another one for your sketch itself. So what I'm doing here is, instead of downloading the serial port library to this online environment and having a local copy, instead what I've done is I'm using something called a CDN. This is a web server on which these libraries reside. And that way I don't have to worry about if they, if there's something like weird with my local paths, or if I'm trying to run an example on my own computer, there's not some sort of like weird issue with permissions. This is a pretty secure way to get these libraries to work inside of your web pages. So you can see here I've got the script for the P5 library itself, and then immediately afterwards, I'm using a different CDN to include the serialport.js library, which is what we need to include so that our sketches can communicate with that server on our computer that's forming that bridge. So make sure that your index.html files, whenever you're using serial communication in a P5 sketch, has this file right here included. Now, inside of our sketch, what we're going to do here is there are a number uh, of methods that are included as part of the serial port library. This example lists a lot of the ones that you're going to find. You don't need these in every single sketch, but it's really useful for this demonstration purposes to have all these in here. So in subsequent examples, I'll remove those as needed. So at the top of our sketch here, we've got two variables. One of them is going to hold an instance of the serial port library itself, and so we're just calling that serial. And then we've got another variable here called latest data, and this is going to hold the information coming in from our microcontroller, and that we can then repurpose other places inside of our P5 sketch. Inside of the setup, we create the canvas, and so this is the place where we're going to draw this stuff on screen. Here I am calling the serial port constructor and storing that inside of the serial variable that was created up here. So every time that I refer to serial from here on out, it's actually referring to this library, this object. So serial.list is a built-in method here that will generate a list of all connected serial ports to your computer. This is useful for debugging inside of your browser or console. And we'll repurpose this in a minute. So when you call serial.open, what you're doing is you're referring to the serial port on your computer that your microcontroller is connected to. In these examples, if you just want to follow the examples and recreate them exactly, you can duplicate the sketch and the index file, and it'll work right out of the box, except for the fact that you need to change this right here to reflect the same name as the serial port on your computer. So you might see, so for those of you on Windows, you would have something that would actually say, COM3 or whatever it is, right? On a Mac or on Linux, it'll look something similar to this. If you need a refresher on what your what name your serial device is connected to, you can go back to the P5 serial control application, and you can just copy it right out of here. So this opens up the specified serial port for communication between the microcontroller and the browser. Uh, so here we've got a callback for when we make a connection to our local computer. And so we're calling this server connected. We've got another one right here that prints out a list of all connected serial devices. We've got one right here, and this is one that you're going to want to keep in future iterations called got data. And this is going to basically, when we receive data from our microcontroller into the serial buffer on our computer, this is where we're going to read that into our sketch and then process it in some way. There's another one here for when we receive an error. Here's one for when the serial port first opens, if you have something specific that you want to do. And then here's one in case the port closes. So you could throw an error, you could give some text. It's just a nice sort of gimme sort of function to help out with some diagnostic information. Again, a lot of these you don't actually need, but for demonstration purposes, they are very useful. So here you can see the server connected function. So when we are connected to, when this sketch connects to our server, it prints out to our console down here, connected to server. Here's the function for listing the ports. So it takes an argument that is generated by this function right here, and then just iterates through all of them and prints it out to the console. Again, the utility function, nothing more. The got open and got close ports or functions that that you saw up there. Again, they're just giving status. They aren't imperative. They're just helpful. And then also the error uh, function that we called up there. This is useful if you're looking into debugging. Now, the errors that are going to get thrown are not going to be quite as useful as the type that you're accustomed to seeing in the Arduino IDE. They're going to be specific to the serial port library, and you'd need to do a little bit digging if you wind up getting some of these errors. Again, this is not imperative to have. It's just a nice full tool for debugging. So the important bit for us is inside of this got data function. So this gets called whenever data appears inside of the serial buffer. So when the microcontroller sends the information to our local server, this function gets called right here. So what we're doing here is we've got a local variable called current string. And what it does is with this command right here, serial.readLine, it reads everything inside of a message from the microcontroller. Now, a message in this case is essentially, if we go back to the Arduino IDE real quickly, it'll basically, each serial print ln statement inside of your Arduino sketch could be thought of as a single line. So what we're doing is, in this case, we're just reading like 1 or 0, and that is an entire line. In more complex sketches that we'll see in the future, we'll be able to see how we can fit multiple variables and from multiple sensors into one line. But for the time being, we just have this one bit of information. So here, after we read that in and we store that inside of this variable, what we want to do is we want to trim off any white space. And white space is characters that get sent along through serial communication that aren't visible. So for example, the new line and carriage return, the equivalent of the enter button that I was talking about earlier, those get attached, and those are not things that are useful to us. They aren't actual values that we can do anything with in the context of our sketch. So by calling this trim function, what we're doing is we're removing that white space and we're just getting the data that we want and nothing else. This if statement right here is checking to make sure that we've got a valid piece of data inside of our string. So if we wind up accidentally sending nothing from the microcontroller, uh, and it's just an empty string, then what this does is it just sort of escapes out of this got data function, and the program carries on as it would normally. So it's just sort of a safety measure. This line right here, this console.log current string, what it does is it prints out the data to our console. And then right here, what we're doing is we're taking this local variable, current string, and we're taking that value and we're storing it inside of this global variable, latest data, right? And that's what we declared this up here at the start of our program. So this is what's going on when we get data. We read in from the serial buffer, we get rid of anything that we don't want, and then we store that into something that we can use elsewhere. So in the draw function here, all we're doing is we're printing out whatever the latest data is. That's going to appear in the very top left-hand corner of my sketch. So we'll just see a 0 or a 1. And if the latest data is a 0, then we're going to draw a circle in the center of the screen. And if the most recent data is anything else, we're going to draw a rectangle. So since we're just sending a 1 or a 0, it's only going to happen, we'll see this happen when we press a button. So I'm going to turn my camera back on. So here you can see my microcontroller, and you hopefully can see when I'm pressing this button, right? So what I'm going to do here is I'm going to go back to the P5 web editor, and I'm going to press this play button. And when I do, over on the right-hand side in this preview area right here, we'll see this is where the sketch actually runs. So we'll see the circle and square appear around here-ish, where my mouse is moving. We'll see the value up here in the top left-hand corner. And then in our console right here, we'll see debug information as appropriate. So I'm going to go and run this. And now we can see here's the values from the console. Inside of the preview window, we've got our 0 and we've got the circle. And so when I come through here and I press the button, we can see that this value changes to 1 and the square appears right here. When I let go, it comes back to a circle. And you can also see this reflected down here inside of the console. Right? So obviously, this is a fairly straightforward example, just using on or off. But you could do that. You could use this for inside of a P5 sketch in a number of ways. Let's say, for example, you wanted to create a physical interface for starting a movie. You could load up your movie inside of your P5 sketch, and then you could use this as like a play button or a pause button. You could use this to start a game. You could use this as an input for a game, like a jump button or something like that, right? So you can make your own version of Flappy Bird. Again, we've talked a lot about like the various uses of buttons in this class. So I leave it to you to figure out like what your use for it will be. So this is the how you would get just input from a single button into your sketch. The next example will build off of this, and we'll do something where we take an analog resistor, in this case a potentiometer, and we'll use that to change something inside of our sketch as well.